An overview of Fabric checks and configuration in the context of OpenShift installation on bare metal servers, provided by iserver application. iserver is an open-source command line application that, based on user input, can install OpenShift on bare metal servers, as well as check or configure data center network for servers connectivity. Check an overview video in the playlist for more information. The focus of this video update is introduction of Fabric checks and configuration workflow step that is executed before OpenShift installation starts. Other videos in the playlist explain the details of configuration and workflow execution per supported Fabric type. Refer also to GitHub for complete explanation of this feature. Fabric step is controlled by a single file, Fabric.json. If this file is not defined in the input directory, then Fabric step does not run. Before going to details, let me explain what type of connectivity between server and data center Fabric is abstracted in the input file. Server, that is also Kubernetes cluster node, may have multiple physical interfaces used for base Kubernetes access, storage subsystem access, or extra networking such as SRAOV. These interfaces may connect to different data center networks, different devices in the same data center network, definitely to different interfaces that may have various configuration requirements. The intention of the model is to capture such complex connectivity deployment scenarios. Everything regarding Fabric is defined in a single Fabric.json file that has two key sections: list of controllers and list of servers, and for each server, list of interfaces. Server interfaces are associated with controller using domain attribute value. Controller definition refers at least to controller identity in case of check mode. It can also refer to configuration intent in case of configuration mode. You will hear me saying check mode or configuration mode in the context of Fabric quite often. You can also find dedicated videos for check and configuration modes. Keep in mind that this mode is detected based on the content of the Fabric.json file. As an example for ACI controller, the domain controller section in blue refers to my API controller, where my API name is locally significant to iserver and paired with real FQDN or IP address of API, as well as access credentials. I am calling such construct a connector. ACI connector has domain value main that is used on server interfaces defined in green. ACI Fabric check video available in the playlist gets to the details of this setup. This is another example of Fabric.json file content that triggers ACI configuration workflow, and more specifically, BGP L3 out mode in ACI. You see that the blue section for controller has more attributes than in check mode, while the green part for interfaces remains the same. ACI Fabric configuration video available in the playlist will give you more insights into definitions and workflow execution. This is quite general update on Fabric controller functionality. However, the key takeaway, and what I hope you will remember after watching this video, is that iserver application can help with data center checks and configurations, supporting various controller types and relatively complex connectivity models.